So as a science teacher, one of the paper creations I came up with was a simple paper sundial that students can cut out and make. It's just two pieces. You can cut them from a single piece of paper, fold this into the shadow stick or the gnomon, and assemble it like so. So I wanted to see if I could adapt the design to a traditional horizontal face garden variety style sundial. And this is what I came up with so far. I just engraved the same face design onto a plaque, a wooden plaque of various sizes. And then for the gnomon, for the shadow casting thingy, I just carved the appropriate shape at the appropriate angle out of a piece of brass or aluminum. And I think they're fairly pretty. The big problem I have with these is they're not really outdoors durable. To be functional, they have to be in the sunshine, but I haven't found a good way yet to be able to permanently mount these outdoors. Incidentally, as I'm recording this, it's about 2:30 daylight savings time or 1:30 solar time. The gnomons, the shadow sticks for the large and the small version, I got at the wrong angle, which is why they don't agree with the one in the middle. The one in the middle is reasonably accurate. Another strategy for sundials is to make an actual dial with a perpendicular stick in the middle to cast the shadow, and then you can get the shadow of the stick to sweep evenly around the circle at a steady pace, just like the hand of a clock, if you line up the circle with the circle of the sun in the sky. So you have the stick, the shadow stick or the gnomon in the middle, pointing at the North Star, and then the sun will circle around the outside edge of the wheel once around every 24 hours, causing the shadow of the stick to sweep around evenly like the hand of a clock. Again, as with the horizontal sundial, you have to make sure this is tilted to your latitude. It has to be tilted to the right angle so that it lines up with the circle of the sun in your sky. Also, you need both sides. In the summer, the sun will shine on the northern side, and you will read the time off of the northern face of the dial. And in the winter, when the sun is lower, it will shine on the south side, and you will have to read the time off the underside of the dial. And on the equinoxes, ideally it will go exactly around the perimeter, around the edges, and shine on the dial sideways. This is a paper version of an equatorial sundial that I made for students. It's just two pieces to cut out. You fold this, you cut a little slot at the appropriate latitude so that this is tilted the right way. You stick a toothpick in the middle, and then you assemble it the right way. And then you have a paper equatorial style sundial. This is my attempt to make a DIY version of an equatorial sundial that you could make with a laser engraver. The base of it is basically the same as a traditional horizontal sundial. It's got a tilted gnomon or stick to cast the shadow. It has to be tilted to the same angle as the horizontal sundial. In other words, this has to be lined up with the axis of the Earth or pointing at the North Star. And the shadow of the stick should sweep around the hour lines just in the same way that the shadow of a traditional horizontal sundial does. The disc, I started with clear acrylic. I thought this would look really awesome in the sunshine. I like the way it casts shadows. However, the drawback with clear acrylic is you can't see the shadow. The shadow doesn't land. When the shadow hits the dial, it passes straight through and you can't see it. It's invisible. So that kind of defeats the purpose. However, there are some other aspects to the clear acrylic that I really like. I lined it up. I drew this line or set of lines right here so that on the equinoxes, the disc should cast its shadow. It should function like an equinoctial or equinox ring. The shadow should just pass straight sideways along this line. And then in the summer, when the sun is higher, the shadow will be lower than the equinox line. In the winter, when the sun is lower, the shadow will be above the equinox line. And then on the equinoxes, it will pass straight along that line. Furthermore, with the clear acrylic, if I polish the edges, it'll act like a lens. And if I set it the right distance, it will focus the light of the sun and make a little shiny, glowing light marker. And then on the equinoxes, that light marker should pass along these lines and tell what time it is. So the clear acrylic does have some really nice virtues to it, but the fundamental drawback still remains that you can't see the shadow of the gnomon, or the shadow casting stick, on the face of the dial, which was the whole purpose of the equatorial disc. I had another thought. What about fluorescent acrylic? This tends to glow at the edges. It gathers light in the sides and channels it out sideways and makes really beautiful glows at the edges. Unfortunately, this works best. Right now the sun is up there. It's around noon. This works best if the sunshine comes in sideways into the face of the disc. If the face of the disc is facing the sun, and then the edges channel the light out sideways. It doesn't work nearly so well if the sunshine is coming in the sides, which is the way it has to be for if I make this the equinoctial disc of a sundial. So that had a lot of potential for looking really beautiful too, but it doesn't work as well as I had hoped for a sundial. And that just leaves us with opaque acrylic. So if I really want a shadow to land on the dial like the hand of a clock, I have to have opaque acrylic. So this one is my favorite. This is my own updated version of a classic ancient Greek sundial. The ancient Greeks made sundials like this, except without the map. So let's start by ignoring the map for a minute. Now they would set up vertical sticks to cast shadows, kind of like Egyptian obelisks, and just watch what happens to the shadow during the course of the day and the course of the year. Naturally, the shadow will pass from west to east during the course of a day as the sun goes from east to west in the sky. But not only that, the path that it takes, the path of the shadow on the ground, which reflects or is a sort of mirror image of the path of the sun in the sky, that curve will shift up and down with the seasons. So for example, in the summer, when the sun makes a long arc high in the sky, the shadow will make a long arc going very close to the shadow stick. It never goes straight overhead. Unless you live near the equator, the sun never goes straight overhead, so the shadow's never straight up and down. But it does get very short. At noon in the middle of summer, the shadow does get very short. On the other hand, in winter, when the sun is much lower, it makes a much shorter lower arc in the sky. The path of the shadow is much shorter and much stretched out much farther to the north on the dial. So this would be the path the shadow takes in summer, because the sun in the sky is making a much higher, longer arc. And this is the path that the shadow takes in winter, because the sun is making a much lower, shorter arc, lower in the southern sky. And then on the equinoxes, this line in the middle is the path the shadow will take. So not only do I have radial lines that will mark the passage of the hours, I have a series of curves, a series of sun paths marked on the dial that will indicate where am I in the solstice equinox cycle. If the shadow is very close to this line, I know I'm near the summer solstice. If the shadow is very close to this line, I know we're near the winter solstice. If the shadow is close to this line, I know we're very near the equinoxes. So not only can you tell time of day by where the shadow falls on this set of lines, you can tell time of year by where the shadow falls on this set of lines. So the ancient Greeks would make dials with this grid of lines marked off, engraved in stone usually. They had a name for them. They called them pelikanon, I believe, if I'm pronouncing that correctly, which was their word for double-bladed axe, because this pattern, this grid of timelines engraved into the stone kind of resembles the shape of a double-bladed axe. So the ancient Greeks made sundials like this, and they had a name for them. They probably also thought of putting a map on it. It wouldn't surprise me a bit. They were very clever people, and I'm sure they realized there's a connection between the sun over the earth and where the shadow falls on the dial. But they never actually engraved maps in their sundials. For one thing, they didn't know the map. They knew only a small part of the world. They knew it was round. They knew the world was a sphere. But what was on the other side was a total mystery. They only had maps for the Mediterranean area, bits of Europe, small pieces of Africa and Asia. It also would have been very difficult, I would imagine, to carve these coastlines properly into the stone. However, we in the modern world, we know the whole globe. We have computers that can project and engrave anything we want in any projection we want. So I thought, why not put the map on the sundial? So what does it mean to have a map on a sundial? Well, if you do it the right way, if you align and orient and stretch your map the right way, something kind of fascinating happens. Notice what I've done with the map. I've put my own location in the middle. I've centered the map on the location where the sundial is to be used. I made this one for Iowa, so I've got Iowa centered in the middle. There's North America, South America, Europe, Asia. I've oriented it so that south on the map points north when I put the sundial outdoors, and north on the map is facing south. So the map is rotated 180 degrees compared to the world around me. And I've also stretched it at the edges, sort of the way the shadows stretch out and get very long when the sun's low on the horizon. So I have to stretch the map out near the perimeter. It's concentrated in the middle and stretched out at the sides. Now if I do all that, if I stretch the map and fit it the right way to the sundial, look what happens. The summer solstice line of my sundial becomes the Tropic of Cancer on the map. The equinox line on the sundial becomes the equator on the map. The winter solstice line on the sundial becomes the Tropic of Capricorn on the map. And all of the hour lines become longitude lines on the map. And now with the map like this, anywhere the shadow falls on the map, that is the place in the world where the sun is directly overhead at that moment. So for example, here in Iowa, if, let's say it's 10 a.m. on the equinox, so the shadow falls right there, at that moment, 10 a.m. on the equinox in Iowa, the sun is directly overhead. What would that be? Brazil, I guess. At, let's say, 4:15, close to the summer solstice. So if the shadow falls right there, in Iowa, the time would be a little bit after 4, and the shadow is pretty close to the solstice line, but a few weeks or a month away. At that moment, the shadow is directly overhead of Hawaii. So the map on my sundial becomes a sun overhead indicator. Notice this region between the solstice lines on the sundial is the region between the tropics on Earth, that part of the world where the sun can be straight overhead, and this part of the world outside of the solstice lines, that's the part of the world where the sun can never be straight overhead. So this represents my second edition. This is what I've been up to lately. I tried engraving it out of oak. I love the grain of the oak. It gives it more of a classic, rich texture, but I don't think there's going to be a good way of combining the richness of the texture with the clarity of the map and the markings. I think I need something without grain. I also tried engraving the compass markings around the edge on a bezel. I kind of like that, but I need to find a way to do it while keeping the laser in focus. And then on the bottom here, I've got a location label with latitude and longitude markings.